All right, welcome to Systems Day 1 of 3. So this little short mini unit's going to go pretty quickly. So these first 3 problems are review from Algebra 1, solving a systems of equation. So all of these are linear systems. So I'm going to remind you that you have 3 cases to solve. You have something called substitution. You have elimination. And you have solve by graphing. At this point, we're not going to solve by graphing. We're going to do these algebraically. So this first one, I see both of these equations are in standard form. So the method I would choose would be elimination. I can look at this and I can say, okay, if I multiply the second equation by 2 and I add them together, then the y's are going to disappear and I can solve for x. So I'm going to recopy the first equation. And then I'm going to multiply the second equation by 2. And then I'm going to add them together. So my y values go away. So I get 7x equals negative 7, x equals negative 1. So now I know that those two lines would intersect at one point. So I'm going to go back to one of my equations. It really doesn't matter which one. I'm just going to choose this first one. And I'm going to plug in that x equals negative 1 and solve for y. So I have 3 times negative 1 plus 2y equals 1. Negative 3 plus 2y equals 1. If I add 3 to both sides, I get 2y equals 4, y equals 2. So for this system, I have a solution at the point negative 1, positive 2. So this second one again, both of these are in standard form. So I need to look at my variables and I need to say, okay, do I want to try to cancel out my x's or my y's? And I'm just going to choose x because it's the first variable that comes. If I multiply this one by negative 3, then I'm going to cancel out my x's. That should be a negative 3. So I would have negative 6x plus 9y equals negative 12 for that first equation. In the second one, it's going to stay the same. So I have 6x plus 9y equals 8. This should be a minus. If I add those together, I get 0 equals negative 4. Both variables canceled. That's a false statement. So there is no solution to this one. Again, this is all Algebra 1 review. So this one is set up for substitution because I know that x is equal to 4 plus y. So I can substitute that in there into the first equation and see what happens. So I would have 6y minus 6 times 4 plus y for the substitution equals negative 24. I'm going to distribute my negative 6. So I get 6y minus 24 minus 6y equals negative 24. In this case, my 6y's cancel. I get negative 24 equals negative 24. That is a statement, so I have infinite solutions. If you graphed those two lines, they would be exactly the same line. All right, so there's your review of solving a linear system. So the goal for today is to solve nonlinear systems. So we're going to be looking at lines and parabolas, maybe circles if they pop up. All right, so we have linear systems. We have 3 different categories. An independent system is a system with one solution. So one solution would be the lines intersect. So remember, these are linear systems. So a dependent system has infinite solutions. So that would be my lines coincide. Or if you took your two equations and graphed them, they would be the exact same line. The last one is inconsistent, and that is no solution. If you graph the two equations, they would be parallel lines. They never intersect. So now we need to go back and classify the three that we did on the first warm-up example. So for this first one here, I have one solution. So that is my independent system. This may show up on the EOC. That's why I'm going over it. The second one is no solution. That's an inconsistent system. And the third one is my infinite solutions where the lines overlap, and that is called a dependent system. Okay, so that was a quick review of Algebra 1. We'll obviously go over that very quickly before the EOC in May as well. Okay, so now we're going to look at some nonlinear systems. These are going to be a little bit different because we're going to be looking at a linear and a nonlinear. So in this one, I have a parabola, which is my first equation because it's a squared. And the second one is a line. So if you think about that, if I draw a parabola, I could have a line intersected at 2 points. I could have a line intersected just at 1 point. That would be called a tangent line. Or I could have a parabola where the line never intersected at all. So for these, you can have two solutions. You can have one solution, or you can have no solutions. So we're going to use the same process for these. And typically, the easiest way to do these a little more complicated systems is to use elimination. So on this one, I can see that if my y's were opposite signs and I added them together, then the y's would cancel. So I'm going to go ahead and take the second one or the first one. It doesn't matter. I'm going to multiply by -1. I'm going to recopy my first equation. And I'm going to multiply my second equation by -1. So I get -2x plus y equals 1. So now if I add those together, my y's cancel. Notice that these first two expressions right here are not like terms, so you cannot add those together. So I end up with x squared minus 2x equals 3. So I end up with a quadratic. So if you recall from the first unit, I need to set this equal to 0. And my first form of solving a quadratic should always be factoring. So it looks like this factors to x minus 3, x plus 1. So factoring is back in your ball game right now. I told you it wouldn't go away. So here I get two values of x. I get x equals 3 or x equals -1, which means I'm going to have two solutions to this system. So now I need to find the y values that go with those x values. So I have x equals -3 and x equals, or +3, sorry, and x equals -1. So I need to pick one of my systems to substitute, or one of my equations to substitute those numbers back into. The linear one is going to be the easiest. So I'm going to take that and I'm going to substitute x. So I get 2 times 3 minus y equals -1. I get 6 minus y equals -1. If I subtract 6 from both sides, I get negative y equals -7. Divide both sides by -1, and I get y equals +7. So one of my points of intersection, or my solution, is 3, 7. I need to do the same thing and plug in -1. So I get 2 times -1 minus y equals -1. I'm still using that second equation. So I get -2 minus y equals -1. Sorry about that. Add 2 to both sides. I get, they're testing the sound system at school today. Negative y equals +1. If I add 2 to both sides, so y equals -1. So my other solution would be -1, -1. So if you graphed the parabola and if you graphed that linear equation, they're going to intersect at the points 3, 7 and -1, -1. Okay, so this second one is another one where I have a parabola, because the first equation is quadratic, and I have another linear equation, so I have a parabola and a line. So again, I have the 3 pieces. I can have 2 solutions, I can have 1 solution, or I can have no solutions. So on this one, I am going to, let's see, I want to keep that x squared, because I can't really do anything to the second equation to eliminate x squared. So I'm going to eliminate y, and I'm going to multiply this one by -1, because I want to keep that x squared positive. So I'm going to recopy that first equation. I'm going to multiply my second one by -1. And I'm going to see what happens. So my y's cancel. So on this one, I have x squared minus 4x. You can't put those together. They're not like terms. Equals 4x minus 16. So I see it's going to be quadratic, so I need to set it equal to 0. So I'm going to subtract 4x and I'm going to add 16. So I get x squared minus 8x plus 16 equals 0. So again, I look to factor. You definitely do not want to apply the quadratic formula to all of these. So this one factors to x minus 4 and x minus 4. Perfect square trinomial. So I only get one value of x equals 4. So I'm going to go over here and I'm now going to find my y value. Okay, so it doesn't matter which equation you substitute into. So again, I'm going to go ahead and put the linear one, so I don't have to worry about squaring x. So I would have y plus 4 times 4, which is basically x squared, equals 16. So I got y plus 16 equals 16. If I subtract 16 from both sides, I get y equals 0. So for this system, the parabola and the line, I get one solution, 4, 0. So that would have to be a parabola, and the line would intersect it somewhere only at one point. So there's only one solution to that system. All right, so this last one, we have a parabola and a parabola. They're both quadratic. So you have several options. You could have a parabola and a parabola that never intersect, so no solution. You could have a parabola that intersects twice, like that, for 2 solutions. You could have a parabola, I don't think we could get it to intersect 4 times, but I could get it to intersect once where it just hits each other. So you could have one solution, two solutions, or no solutions. Okay, so I need to keep my x squared because I know I'm going to have to solve a quadratic at some point. So I'm going to eliminate my y values. I'm going to multiply this first equation by 2. So I get 2x squared plus 4y equals 12. Organization is a key on these problems. Here I get 3x squared minus 4y equals 8 by just copying the second one again. If I add those together, my y's cancel. I get 5x squared equals 20. So that's a pretty simple quadratic to solve. I can divide both sides by 5. And if I take the square root, this is where it is a key to get that plus minus in there, or you lose one of your solutions. Okay, so I have x equals 2 and I have x equals negative 2. So I'm going to pick one of my equations to substitute into. I think I'll choose this one because everything's positive. So for this one, I have 2 squared plus 2y equals 6. I have 4 plus 2y equals 6. 2y equals 2. Y equals 1. So over here, I have the point 2, 1 as a solution. If I plug in negative 2, I get negative 2 squared plus 2y equals 6. Again, I have 4 plus 2y equals 6. And I'm going to get the same x value when I keep solving this. So 2y equals 2, y equals 1. But then you have to remember that your x value is a negative 2 here. So those are two different points in the graph. So that would be a situation like this, where my x values are opposite, but my y values are the same. So it could look something like this maybe, where that would be a 2 and a negative 2. And this would be 1. All right, so there is a little dabble of solving nonlinear systems. You do have a worksheet to complete. Make sure you show all your work, and please use a pencil. Have a great day.